Hello, everyone. How are you guys doing today? I have two news, one good, one bad. Which one you want to know first? Bad? I decided your first exam date, it will be next week, Friday.
When was the result?
I didn't make anything, but I was thinking of giving you at the end of the day, at the end of the semester, at the end of the month. But then today morning, I realized there's so many materials. Then you have to cover for your exam one, and then you may fail the exam. So I decided to give you the exam next 2 week with less materials than what I was planning before. Okay. So previously I was thinking to give you after we finish chapter 10, but today morning we decided no, it will be too much. So before we finish chapter 10, you're going to take your next exam Friday. So your first exam next week Friday. And now do you want to know the good news? There will be no quiz this week. Uh-huh. So today or Friday, I'm not going to give you any quiz. Instead, I'm going to give you an exam next week Friday. Okay, so just now I experienced something really weird I never experienced before in my life. I went to the restroom, and when I came out to wash my hands, there was a guy in the restroom. Yeah. So I assume he's gay, but I never thought just because you're gay, they would use female restroom. So like when I saw him, I skipped a beat of my heart. Like for the first time in my life, like I went outside and there was a guy standing in front of me. Like I, I'm not sure what to feel: scared or happy or what. Like what am I supposed to feel? So yeah, like my heart is still beating because I'm not used to seeing anyone. So it's my first time in my life. So no, I did watch it and I was looking at him like, is it really a guy or a woman? Guy or woman? And then I was sure no, it's a guy actually. Like the way he looks like he's a gay, but he's definitely a guy, not a woman.
We're not having quizzes 3 days. Are we gonna have the quiz on Tuesday next week?
That's I'm going to decide later. Most likely no, because you're going to take an exam anyway on Friday. But definitely this week I'm not going to give any quiz. That's for sure. Um, okay, so that is new for me. And there's another thing new for me. I don't have my glasses, Jenna. I forgot them at home. So like my whole day is like, man, something like everything feels so weird.
Everything that could go wrong today, it went wrong for me.
Exactly. Like so many weird things I'm experiencing today. Yeah. Um, what else? Don't forget to submit your 8.1, 8.2, 3.6 homework quizzes by tonight midnight if you haven't done them yet. Okay. Anything else? I'll try to make a review sheet for your exam one this week so that you have an idea what will be in the exam. I didn't make the exam yet. I didn't even know that you're going to have an exam next week. Today morning, when I was covering my materials with other students, I feel like my head is about to explode because there's so many things we covered in one day. This is like
I think last week you mentioned like that it's gonna be something like in September or like towards.
so I thought probably it will be end, but now I know it's not end. It will be next week Friday, so 19. Mm-hmm. And then one good news: when you'll be back, there will be actually a few vacation days. Let me see the schedule. Not here. 23, 24. Yeah, I noticed there are a few off. We have this month. 22, 20, 24, no classes. Yay. So you're going to have our exam on 19th, and then you're not going to see me on Tuesday. And then you're going to fit again Friday. Yeah. 3 days off. Cool. So we have Tuesday, Friday. Yeah. Good thing we decided to have the exam next week. Okay, any question before you start? Any comments, concern, complaints so far? Nothing yet? What do you dislike about this class? Any compliment?
I have to say not to dislike, but I have to say from high school, like, well, it's a bit older than everyone here, but like, and I was like, I grew up in different countries. So from high school, math wasn't my thing, and I didn't like it. But like with your, so I was real scared like starting this class, but like with you, I feel like I understand it, and so far,
thank you.
Thank you.
Cool, cool. Any other comments? Anything you dislike so far? Besides quizzes. I know you hate quizzes. I know that. Besides quizzes, any other comments? Any complaints so far? No. You know, I used to give questions as a homework about yourself. Like, tell me about what you like, what you dislike about math, all of these. And this time, I was making a huge list that I couldn't end up finishing it yet. But I love to hear about my students, what they think, how they learn, so that I can adapt my teaching style as part their learning style, so that you guys can learn more and better in my class. So anytime you don't understand anything, you get confused or anything, please let me know. Don't feel shy. When you ask me a question, assume the other people, their status. Okay? They don't affect you. Assume that. So today we're going to do rest of 5.1 and we are going to start 10. And we are going to learn few rules. Not few, a lot of rules about exponents. As long as you can remember all of your rules correctly, all the exponent questions will be easier for you. So I will suggest to put all the rules I'm going to give you, put them together in one sheet of paper, and then have them available in front of you all the time. When you do the homework, when you take your mind method quizzes, or when you do class practice. Question.
What's the topic name?
5.1 exponents. And the topic we are going to learn now is exponent rules. Exponents. 5.1 and then chapter 10, they all talk about exponents. So they go together. Okay, so I know many of you already know these rules. So I'm not going to start with the rules first. I'm going to start with how do you derive them. Okay. So we already know one thing from before, that our power tells us how many times to multiply our base, right? We already learned it before. So in this example, we have our base 2 squared and we have our power 4. So how many times we are going to multiply what? 2 squared, we are going to multiply 4 times. So 2 squared times 2 squared times 2 squared times 2 squared. This is what power telling us, the 4 power. Multiply your base 4 times. But then individually, they have 2 power also, right? So all of them, they're telling us multiply 2 twice. So 2, 2, 2, 2, 2, 2, 2, 2. So my question is, how many times you see 2's now? All together. 8. So can you derive the formula? If we have 2 powers together, what can you do? Multiply them. So first rule is, it doesn't matter what is your base. If you have multiple powers, multiply all of them. M times n. So if you ever forget the rules, do you have to multiply or do you have to add? Just derive like 9. Do some examples and figure out what's the ruling, addition or multiplication. The next one, we have our base 2x. So how many times you have to multiply the 2x? 4 times, right? Because of 4 is power is 4. So 2x times 2x times 2x times 2x. So how many times you see your 2? 4. How many times you see your x? 4. So can you guess the rules here? The rule here? Distribute. If you have multiple base or multiple element in your base, but only one single power, you have to distribute the power to everything inside your base. So these are second rule, distribution. Distribute the power. A to the m times b to the m. I used to give the rules first and then do examples. And then one day, every semester we get observed by department. So one day one of the observer came and then he observed us as a whole class. And then at the end of the class, he said, well, you shouldn't do that. So I was like, what? He was like, you shouldn't just give them the rules. So I was like, why? What's wrong with that? And then he was like, well, first you should explain where from the rule came, where the rule came from. So you have to show them how to derive the rule so that when they forget, they can be independent. They can derive their own rules. I mean, not own rules. They can derive the rules by their own, on their own. Okay. So from that time, I realized, yeah, that's a good thing actually. If I simply give you the rules, you may forget them. But if I show you how to derive the rules, then even if you forget them during your exam or any time, you can simply derive them like the way I am doing it. So if you don't understand what I'm doing here, let me know. I'm showing you the examples, how examples helps us to get the rules for each exponent component. So previously we have multiplication, we distributed. Now we have division. Let's see what happens. Our base here is 2/3, right? So how many times you have to multiply this 2/3? 4. 2/3, 2/3, 2/3, 2/3. So how many times you see 2? 4. How many times you see 3? 4. So what did we do here? Again, we do the same thing, distribution. So it doesn't matter whether you have a multiplication or division on the base, you're going to distribute them. So distribute your base. Distribute the power on your base. A to the m, c to the m. Any questions so far? Now it's the other way around. We're multiplying the bases with their individual powers. And fortunately, the two bases are the same base. So basically, we have same base multiple times with their individual powers. So let's see what happens now. The 2 cube means 2 times 2 times 2, right? And what does 2 to the 4 mean? You're multiplying 2, 2, 2, 2. So how many 2's you see? 7 total. So what did you do here to get the 7? Add. So next rule says, same base with the individual power, keep the base in multiplication, but add the powers. You may have more than 2 powers. You may have 4 or 5. Same base with 5 different powers. No problem. Just add all of them. But keep the base only once. And now the last one. In division, we have the same base, but we are dividing this time. So 2 cube means 2 times 2 times 2. And 2 to the 4, you're multiplying 4 times. And then what happens? They cancel out 1 by 1 by 1. So what is left? 2 left. Where? On the top or on the bottom? On the bottom. Then what is left on the top? 1. In multiplication or division, we never get 0. We get 1 after the cancellation. Now the other one. 2 to the 4 on the top, but 2 cube is on the bottom. So 2, 2, 2, 2. And then 2, 2, 2. Same thing is happening. But this time, what do we get? We get 2 over 1, which is 2. So what you're observing here? In division, what do you do? We subtract the powers. But there are 2 scenarios in the subtraction. If the denominator is bigger, what do we get back? Fraction. Denominator big means we have a fraction. But when the numerator is big, what do we get? Whole number. So in division, there are 2 scenarios. You may say, well, I'll just subtract, I'll get negative answer. Well, you can have a negative power, no problem, but you cannot leave a negative power. Anytime you have a negative power, you must convert them into positive power. So why you're wasting your time? Instead of writing it the negative power, just follow the rules. Denominator big means fraction, numerator big means whole number. So we have 2 scenarios here. When the numerator is bigger, we get a whole number. So the result goes on the numerator because our numerator is bigger. The result is supposed to be on the numerator. But when the denominator is bigger, the result goes on the denominator, a to the n minus n. So whatever is big, we keep that and we subtract the smaller one from the other side. And this is our formulas. Any questions so far? So these are the 5 rules you have now, for now. When you have bases, depending on what base you have, what powers you have to follow these 5 rules. Now, these rules, I put them together here. You can ignore this one. We are going to learn that a little bit later. So for now, these are the main 5 rules. 1, 2, 3, 4, 5. Now let's use them to do some examples. Fun examples. The first one says 7 to the 4, everything to the power 5. So what do you do? Go ahead. Multiply 4 and 5. So keep your 7, but multiply this. You get 20. And 7 to the 20 is a big number. So don't waste your time figuring out how much is that. Just leave it alone. When something is big, leave it alone. Volunteer for the next one. Distribution property. So what do you get? Eight to the 9, 6 to the 9. And again, these are big numbers, so leave them alone. Next volunteer. As an exponent to the fraction of 3. 3 to the 8. Perfect. So in multiplication division, we distribute. When you have more powers, multiply. Next volunteer.
This one you can add an exponent.
Same base in multiplication, add. So keep our base 5, we add 7 and 8, we get 15.
Basically, the result, since the 8 is at the bottom, it's like bigger than the 6. It's the fraction, so there's gonna be 1 at the top and 9 on 2, because like 8 minus 6.
And then since 2 is a smaller number, so you can actually do more, right? What is 9 squared? 81.
That's like, if it's like a small one,
Smaller
we can
number?
do that, we should. Okay.
Like when you're up to 2 or 5, like power 2, power 3, power 4, power 5, distribute. And if you have something big, ignore.
The same applies to my math class, like when you're gonna do algebra.
I think so.
Okay.
And in my math lab, usually they have smaller numbers so that you can work with them. The last one, my last volunteer. Why is the whole number? We don't need the one. 81. So denominator bigger means fraction, numerator bigger means whole number. See, 5 rules, 5 examples. Any question from anyone? Then more rules. And this time our rules are based on only 3 bases. Positive 1, negative 1, 0. And power. You copy them and let me fix something here. Ready? The first rule says a to the power 0. A means anything anything. Anything except 0. This is what A means. Anything except 0. So if you have anything except 0 to the power 0, can you guess the answer? Good job. It's 1. You know why I said except 0? Because when you have 0 on the base and 0 on the power, what happens then? It should be 0, right? But actually, no. We have no idea what is 0 to the power 0. So it doesn't exist. Whatever we don't know doesn't exist. That's why when you have 0 power, there's only 2 scenarios. Either the answer is 1 or the answer doesn't exist. So anything you have besides 0, the answer is 1. But when you have 0 on the base, the answer doesn't exist. So for 0 power, 2 cases. And now the most generous one, positive 1. When you have positive 1 and you raise it to the any power, what's the answer? 1. 1 is the most generous number. It doesn't matter what we throw at it. We can throw a positive number, negative number, 0, whole number, fraction, decimal. It doesn't matter what you have on the power for 1. The answer is always 1. Always. And then you have negative 1. Negative 1 is a little bit picky. Depending on what we give to negative 1, it spits out different results. When you have negative 1, add many times. It could be add fraction or add whole number. But that's the main concept is add here. If negative 1 has anything add, what's the answer? Negative 1. For example, if you have negative 1 to the power 3, it means negative 1 times negative 1 times negative 1. So anytime you multiply negative add many times, the answer is negative. And it doesn't matter what two they give you. 1, 2, 3, 4, 5, doesn't matter what number you have. When you multiply, just multiply the numbers. In our case, we have only 1, so it's negative 1. Also, if we have negative 1 to the 1/3 power, it means finding a number. When you multiply that number 3 times, the answer is negative 1. Can you find such number when you multiply the same number 3 times, the answer is negative 1? What is that number? Negative 1. Negative 1 times negative 1 times negative 1 is negative 1. So negative 1 doesn't matter whether you give add whole number or add fraction power, the answer is negative 1. So negative 1 is most generous, negative 1, with that power. But when it comes to even, it becomes picky. For even power, if you give them even integers like 2, 4, 6, 10, if you give them negative, if you give a whole number, even whole number to the negative 1, what's the answer? Negative 1 square is 1. Same thing, if you multiply negative 1 even many times, it doesn't matter how many times, as long as you are multiplying them even many times, the answer is positive 1. So negative 1 turn into positive 1 if you multiply them even times, and negative 1 stays negative 1 if you multiply add many times. And now we have another scenario. What if we give even fraction, like negative 1 to the 1/2 power? So let me show you an example here. -1 to the 1/2 power. It means find a number when you multiply twice, the result is -1. Can you able to find such number? You're multiplying same number twice, the answer is -1. Not possible. So our answer here is DNA. Does not exist. Yes. So -1 you can multiply whole number time, but it cannot have a fraction time. When you have a fraction power on the -1, it doesn't exist. And then we have two more rules with zeros. So one of the rule we already know. When you have 0 to the power 0, it doesn't exist. Now you're thinking, well, if we cannot put 0 to the power 0, what if we put 0 to the positive power and 0 to the negative power? What result we get that time? Let's start with 0 to the positive power. The last one. 0 to the any non-zero positive. Non-zero positive means it's not 0. Besides 0, any positive number. What are the positive number we have? 1, 2, 3, 4. So if I give you 0 twice, 0 square, what's the answer? If I give you 0 cube, what's the answer? If I give you 0 to the square root, still 0. So 0 with anything positive, answer is 0. So we know 0 cannot take 0, but it does take positive numbers. As long as it's positive, it doesn't matter it's whole number or fraction, it will always be 0. That means the last one. What if we give a negative number? For example, here, 0 to the -1. Later, it should be 0, but later we are going to learn a new rule. When you have a negative power, you cannot leave it alone. Negative power, to make it into positive, we have to convert that into a fraction. So 0 to the -1 is same as 1 over 0. Now my question is, if I give you one pen, I'm telling you here that divide that pen into 0 pieces. Can you do that? So what's the answer? You just told me you cannot do that. Doesn't exist. If you cannot do anything, it doesn't exist. So this is doesn't exist. That means 0 is the worst one. It cannot take 0 power. It cannot take negative power. It can only take positive power. So these are the 7 rules with one sub rule about 0, 1, and -1. Any question? Okay, let's do some example. Volunteer for the first one. 1/2 to the power 0. What is anything not 0 to the power 0? 1. So you don't even have to think. You just have to apply the rule. Anything not 0, if you raise it to the power 0, the answer is 1. How about B? -4x, it doesn't matter what you have. As long as your base is not 0, the answer is always 1. How about the next one? We have -9x to the 0. Good job. So we have two scenarios here. One is -9 and one is x to the 0. So Panda says, what are you supposed to do first? The multiplication or the exponent? Exponent. That means leave your -9 alone and tell me what is x to the 0. 1. Because anything not 0 to the power 0 is 1. So x to the 0 has to be 1. And now you're doing the multiplication. What do you get? -9. Sometimes you may see a single base to the power 0. Sometimes you may see a multiplication. Now we have something that is a little bit more advanced. Can you guys see the numbers, or do you want me to write it bigger? You can see. So we have 3y to the 5 on the top, -2 x cubed on the bottom. And everything is raising to the power 4. Good job. The first one is distribution. Since everything has the power 4, so you have to distribute the power 4 to everything inside. So 3 to the power 4. Y to the 5 to the power 4. -2 to the power 4. X cubed to the power 4. So we use distribution property. Next is what?
Power 4.
What is t to the power 4? You're multiplying 3 how many times? So multiply 3 times 3, 9 times 3, 27 times 3, 81. You're going to memorize this. T to the 4, 4 to the 4, 4 cubed. All these numbers you have to memorize. Or even if you don't memorize, it's okay. Just know how to derive them, how to multiply them. Okay, what we do when you have 2 powers? Multiply. So same scenario is here. Multiply. So y to the how much? 20. And x to the 12. Thank you. And now how about -2 to the 4? Good, 16. So -2 to the 4 means -2 times -2 times -2 times -2. So here you can actually applying the negative rules. -1 to the even turns into positive. And instead of 1, here you have 2, so you're going to multiply 2 4 times.
Negative.
If you multiply -1 even many times, the result is positive 1. Even many integers. So 4 is an integer.
Base has to be negative.
If the base is negative and you're multiplying even times, the answer is positive. Even integers. But if you have even fraction, it doesn't exist. Okay, so this is our final answer. Can you simplify anything here? No, right, because 81 and 16, they don't have anything in common. Same thing, x and y, we cannot simplify because they are different variables. Any questions so far? If this is too small, let me write it bigger for you. We have p to the 5, q to the 6. And we are dividing by p squared, q to the 8. Simplify. You did enough. Someone else besides him. Volunteer. What do you have? Multiplication or division? Division, right? Give a divide sign. So in division, what do you do? Add or subtract? Subtract. So based on your power, you do different subtraction. For P, which one is bigger? So what will be the result for P? Whole number. P to the 3. And for Q, what is happening for the Q? Denominator is bigger, so it becomes a fraction. Means the denominator. Wait a second. Even if you write 1 over Q square, at the end you have to multiply with P cube. So when you have multiple variables, whatever you have on the top stays on the top. Whatever you have on the bottom, just put it on the bottom. You don't have to write 1 over. You can simply put them together. Any question? Was anything confusing so far? So all of these are rules, okay? I'm not doing anything besides rules. Then that's how it will be Q on the numerator.
It would have been 1.
9 minus 8 is 1, so you will have Q to the 1 on the numerator. The last question from 5.1. Find the area of the rectangle. So you should tell me what's the area of any rectangle. What's the formula for the area of a rectangle? Length times width. And now based on that, you are going to find the area of this rectangle. What is the length of this rectangle? 7x to the 3rd feet. 9x to the 6th feet. And now you do multiplication. So how do you multiply? 9 and 7, they are numbers, so you're going to multiply them together. What is 9 times 7? 63. And then we have x cubed and x to the 6 multiplication. So x cubed times x to the 6. In multiplication, what do you do with the powers? Add. So how much you get? X to the 9. So this is 63. And don't forget about a unit. You're multiplying feet with a feet. So what do you get? Feet square. That's why area of anything has a unit square feet. So this is 63x to the 9 square feet. Any question? So you're done in section 5.1. So next week by Tuesday, definitely you're going to do 5.1 homework. And now we are starting 10.2. And 10.2 is a little bit longer. But more rules. The first rule says when you square root, it means you have 1/2 power. So any type of radical means they're fraction power. When you have a number inside your square root, like number 2, nth root of x, it means x to the 1 over n power. So the rule says whatever you have in the radical, that goes as a denominator on the power. So it's x to the 1 over n. And this is x to the 1 over 2. It's 1 over 2 because square means 2. So square root means we have a 2 denominator on our fraction power. The next rule says, well, what if we have a number in the radical and also a number on our exponents? So what do? So when you have m root of x to the m, you can write them the numerator, the whole number, the exponent goes in the numerator, the fraction goes in the denominator. So it's x to the m over n, x to the m over n power. So when you have two numbers, one on the top, one on the bottom, you can rewrite them as the denominator goes inside the radical and numerator goes on the power. And then you can write in two different ways. Either you can put the power inside the radical or you can put the power outside the radical. All three things means the same thing if your base is a positive number. If the base is a negative number, then it's false. It's not true anymore. So in order to be all of them to be same, the condition is you have to work with a positive base. It could be 0, but it has to be a positive base. All three things. Here, only for question 3. All three things means the same thing. If the base what you have here is positive, then it's true. If you have negative, it's not true anymore. Question 4 starts with negative power. When you have negative power, we hate it. We always hate anything negative in our life. So anytime negative is seen, you have to make it into positive. So all you have to do is turn into fraction. Or if you already have a fraction, all you have to do is switch them. Switch their position, they will become positive. So x to the negative 1 is 1 over x, and x to the fraction negative is 1 over that x is a positive fraction. To the negative n means 1 over x to the positive n. And when you fraction to the negative power, all you have to do is flip your fraction, the negative power will turn into positive power.
For number 2 and 3, is the x in the denominator or outside?
X is inside your radical.
No, when you, at the end, when you simplify it, like number 3 in the red says n over n. Xn, so is the x with the n or outside?
X is the base.
Is the base and then
And then m on the numerator, n on the denominator
exponent?
as an exponent. And these are the last set of rules. So I gave you all the rules you're supposed to know for this class. Plus, you're going to use them in your pre-calc and if you take more math classes. So put all the rules together in one page and please take a look at them every single day. I may give a whole page of examples where you have to apply all these rules. So if you know your rules, you'll be able to do them. Like around 30 questions. Around 30 questions on the rules. Solely on rules. Now let's do some example. We have 4 to the power 1/2. Let me write it nicely. 4 to the power 1/2. The next one is 64 to the power 1/2. And this is 64 to the power 1/3. Yeah, so they give us power as a fraction. You have to decide what it simplifies to. When you have square, denominator is 2. Convert into radical because you can see what is radical. We are familiar with the radical sign. So 1/2 means square root of 4. And we know what is square root of 4, right? 2. So when a 2 denominator, convert into square root. So what's the next one? 64 to the 1/2. So this 2 means you have a square root of 64. And what is square root of 64? 8. But I'm not going to change 1/3 into cube root because I don't even know what is cube root, right? Like, did you guys work with cube root before? Not many people. So if you haven't worked with cube root, don't waste your time rewriting as a cube root. Instead, rewrite your base, this thingy. So keep your 1/3 power because it's unfamiliar number. Keep it and rewrite 64 into a number to the power 3. Can you think of a number if you multiply the same number 3 times, turn into 64? 5 times 5 is 25. 4 times 4 is 16. 16 times 4 is 64. Yep. So the 64 is 4 to the 3. Well, you may wonder, like, why didn't I write 8 square? Why did I write 4 cube instead?
Cube side of 1/3 of the exponent.
Our goal is the denominator. We hate denominators, right? We hate negative, we hate denominators. So in order to cancel the denominator, we look for something to the denominator many times. So since we have the same power and same denominator, we cancel them happily. And you observe what is left. 4 on the base and 1 on the power. So what does that mean? What do we have? 4. I'm bringing my 1 down because later it will not be 1 anymore. It will be different numbers. So you have to bring your power down to simplify at the end. So main idea, when you see 1/2, convert to square root because you know what square root is. Besides 1/2, if you have any other power, leave the power alone, rewrite your base in terms of the denominator of the power so you can cancel. Any question? And yes, you can use you can use other methods to simplify them, but I found this is the most less confusing method. 2 more examples.
So.
What is your base? -9 or +9? If I give you this also, -9 with the 1/2. So now what is your base? What's the difference between the first one and the second one? Are the same or they're different? They're different. Negative parenthesis makes a huge difference. Anytime you have a parenthesis, whatever is inside, that's your base. So here you have -9 square root. But for this example, it's a negative times 9 to the 1/2. When you don't have a parentheses, it's a multiplication. So it's negative times 9 to the 1/2 means square root means, sorry, 1/2 means square root, and you have 9 inside. This is the time. So negative times square root of 9. So it's negative and then 3. Now for the next one. Remember the one rule I showed you before? Negative 1 with even fraction. What was the answer? Negative 1 with an even fraction. Look at your notes. Negative 1 with an even fraction. It doesn't exist. Instead of negative 1, this time we have negative 9, but it doesn't matter. If your base is negative, it cannot have even fraction. Why not? Because this thing is asking you, find one number multiplied twice. The answer is negative 9. What that number is? Can you find that number? No. Because when you multiply anything twice, it has to be positive. This doesn't exist. For now, later we are going to learn that this is actually not 3i. We're going to learn that later. For now, for example 1, it doesn't exist. So there is a difference between having a parenthesis, not having a parenthesis. So since now you know the difference, what's the answer for the next one? I mean, you don't have to write it down. I mean, you don't have to tell me right away. Think about it. What is your base? Negative 81 or positive 81? Base is negative 81? Do you have the parentheses around negative 81?
So it's gonna be negative
Times the 81. So it's multiplication. And since it's 1/4, we are not familiar with 1/4. So keep your 1/4. We don't know what is 1/4 means. Instead, we are going to rewrite our 81. So what we are looking for?
What number can you multiply 4 times?
4 times. So what number? 3. You multiply 3 4 times, it will turn into 81. And we did it before in our one of the example, right? 3 to the 4 was 81. Why we use 3 to the 4? What is our goal? Cancel the denominator 4. We bring our negative down because multiplication, and we have 3 ones, negative 3. Because negative is still there. No parenthesis means negative is a multiplication. Inside the parenthesis means it's the base, negative. Any question? Was anything hard so far or confusing? Okay, so we know fraction and these rules, the thing I said before about the negative 1. If you have negative 1 even fraction times, we don't know what the result is, so that says DNA. Based on that, instead of having 1, you can have 4. Oh, let me change the color. You can, instead of having 1, you can have any numbers. It doesn't matter what number you have. If you have a fraction, if you have a negative on the base, an even fraction, it doesn't exist. If it's inside the parentheses. Now let's do something with the negative power. So you can do a few examples on your own. Let me skip all of these and go to negative power, like this. Simplifying negative powers. We cannot leave the negative powers alone. We are going to convert them into positive. But it's the same rule. Keep your negative at the end, turn that negative into a fraction. So instead of writing 16 to the negative 3/4, we are going to rewrite our 16. Oops. We are going to rewrite our 16. How do we rewrite the 16 here? 2 to the 4th. What is our goal? Why did we use 2 to the 4th? Cancel the denominator. So we left with 2 inside and negative 3 outside. And now we are going to rewrite the negative as a positive. The negative turns into fraction. We get 2 to the positive 3. We can always convert a negative power into positive power by making it a fraction. But if you already have a fraction, just flip it.
Instead of doing the beginning, I just write 1/16.
It became diamond. You can do that, no problem. But from my experience, what I've seen is people make the fraction fast, simplify the denominator, and forget the numerator. They give me a whole number answer. So that's why I suggest don't convert the negative into positive at the beginning. Bring it at the last step so that you can see the fraction, not whole number as an answer. Volunteer for next number.
That's what the denominator means a number that times itself once would equal 16. You take 4 and 4 squared, and then that cancels out the denominator, and then you have 4 to the negative third. But then that would get you a fraction 1/4 to the fifth.
And then you have to say what is 4 to the third? 4 times 4 times 4. 64. For smaller number, yes, you have to write. For bigger number, if it is 30, leave it alone. It's too big. Any question? Okay. Let me skip all of these and go to something like this. Let me write it bigger. We have. Oh, can I flip my page? Does anybody need extra time to copy that? Okay. Let me do an example here then. Drill. Mm. 3x to the negative 2, 4, and let's say 4x to the 2, negative 3. So if you have something like this, again, exponent rules. All are exponent rules. What do you do first? Distribute. The numerator and denominator, they have the individual exponents, so you have to distribute them individually. Bless you. So 3x to the negative 2, 4x squared. The numerator gets the power 4. Let me change the color to green. Numerator gets the power 4. And denominator gets what power? -3. Now 3 to the 4, we have no problem because both of them are positive. So what is 3 to the 4? 3 times 3 times 81. Then we have double powers. What do you do with them? Multiply. So x to the, and the denominator x to the -6. And this 4 has a negative power. We don't like negative powers, so leave it. Every negative power, leave them alone. Why? Because our life will be easier if we can make all the negative powers into positive powers, right? If we can get rid of all the negative people from our life or negative things from our life would have been so easier, right? So we are going to the same thing here. We cannot move everything negative from our life, but we can move every negative things from our math. All you have to do is switch the position. X to the 8 has a negative on the numerator. Bring it on the denominator. It will become positive 8. So let me actually do and show. So 81 doesn't have any problem. Keep it 81. X to the -8 has a problem. We don't like -8. So we bring it in the denominator. And it becomes x to the +8. Then in the denominator, 4 has a problem. It has a -3 power. So move it up. Next to the 81. The -3 will turn into a +3 power. And lastly, this -6, we hate it. So we bring it on the numerator. And it will turn into a +6. So anything negative, just switch their position. For example, when a rich friend has some problem, attitude problem, or his money problem, make him poor, he'll become, what do you call them? Generous, or he'll become nicer. And when you have a very poor kid who has all negativity about his life, he wants to die and everything, make him rich, he'll prosper. So whatever you have, switch the position, they become better. So here we observe that we have like terms in division. What do we get back from this division?
X squared on the numerator.
On the denominator. 8 is bigger on the denominator, so the result has to go on the denominator. And on the numerator, we have 81 times 4 cubed. What is 4 cubed? 64. And in the exam, you're going to multiply them without using calculator. So we have 64 times 81. Let's do it manually. Do you remember how to multiply manually? No? You take the right number on the bottom and you multiply each one of them. So 1 times 4, 1 times 6 gives us 64. And then you leave one space blank. It's a placeholder. We use 0 on that place because you're telling others that now you're going to go to the second digit, to the 10th digit, to the multiplication. So you leave our first digit alone and you go to the second digit. And we do the same thing. We multiply 8 times 4, which is 32, but 32 is 2 numbers. We cannot write two numbers at the same time. So we write only the right number. So from 32, we write the 2 on the bottom, but 3 goes on the top as an addition. Next, we multiply 86. What is 8 times 6? 64. Sorry, 48, right? And then you add that extra number. 49, 50, 51. You put it here. The first line is the product of the first digit and the numerator. The top. The second digit is a multiplication of the second digit and the top. And then at the end, you're supposed to add these two. And you have to add manually, right? I hope you do. What is 4 times 0? 4. 6 times 2? Not times, so you add. 6 plus 2, 8. And then we have 5 and 1 with nothing, so we'll leave them alone. So final answer is 5184 over x squared. We actually covered entire almost 2/3 of 10.2. Now for the rest of the question, let me give you them. So you're going to try on your own or with your friends or with your neighbors. Whatever I skipped, let me put them together. Come on. Where's my mouse? So what did I skip? Okay, I skipped that. Yeah. What? Put all of this together. This question will be the non-calculator portion. So you won't be able to use it. Okay. So left and right, try all of them. Okay. These we are going to do another day, but we actually cut them. Give me 1 second. Oh, in this exam, you're not going to have any calculator portion. Everything will be non-calculator. One second. It is 64. So page. I missed this. Okay. Go ahead, enjoy. All of these are going to simplify. Simplify the following. You don't have to work alone. You can work with your neighbors. Today's 99. Ashley. Jelisa. Jelisa. Michael. Lady. Lola. Jonathan. Jonathan Diaz. Reina. Lee. Denisa. Denisa. Samantha. Nicole. Andy. Priya. Caitlin. Add to Caitlin. Caitlin Hack. Andrew. George. Mariana. I forgot, it's Mary or Mari?
Maria.
Maria. Danielle. Fatumata. Azmain. Shuwing. Chloe. Oh, sorry. Ethan. Sorry, Ethan. My bad. Kathleen. Brennan. Raim. Sahana. Leonardo. Brian. Brian R. Brian V. Gian. Oh. Alex. It's Gian, right? Gian. Alex. Anastasia. Wow, almost everybody is here except Jonathan. No, Jonathan. Is there anybody whose name I did not call? So how are you guys doing? Good? If you don't know, poke your neighbors. Give them a hard time to explain it to you. I'll give you 5 more minutes and then you're going to do them together. Or you can have all 10 minutes and I completed everything with my morning class. You can simply watch the recording for the solution. Anything else? No. Most of the zero and ones. It says anything to the power zero. You should write it down. What is A? Mean anything not zero. So that you got anything not zero. So this is anything not zero. So that's anything not zero. That's why I said write all the rules down in one page and then have it available in front of you. So one thing that why you're dividing. It's multiplication, so why you're dividing? You can divide. That is multiplication. Multiplication. So the rule in multiplication has to do the powers. What is 1 times 2? What is 2 times 2? What is 1 times 2 times 3? The multiplication doesn't matter how you have them, but then you're going to multiply everything once. So even though they're in one pair, they have a pair, but the result is you're multiplying all of them once. So you have 3 y7 and then you have y2. You're multiplying one, but in multiplication you want to add box. So you have to combine the two. Then you have z7 and z3, you're multiplying them, but the power inside the circle. The only thing doesn't have any part now is extra part. Yeah, extra part, you know, brand. No, test. And then you ask in the font for the extra z. So the hard part. Here's your multiply. It's like 1 times 2 and then 2 times 3. So basically you have 1 times 2 times. Multiplication we multiply only once. You cannot go over it.
Y7.
I see.
You multiply it. It's like you're multiplying 1 times 3 parts and you're multiplying 2 times 3. But then what do you have? 1 times 2 times 3. So same scenario here. We're multiplying everything once. When you multiply, it's the same thing twice. For y and for z. So the two rules. In multiplication, in the same way as you combine the powers. Like that. Because of the rule. Can you show me the rules? What the rules do it? Because that is the 0 and 1. Only note and then maps. So the rule is the question has after the so as long as we have anything maximum of this, but the power is 0, that's this. Yeah. That's so write the rules down on a paper and we have it in front of you in the paper. So you have to go one, not X one. No, it's anything to the power 0 is must. If the power is a space in 0, anything not 0 to the power 0 is 1. And then multiply everything once. And then you multiply everything once, you see the same white cross. You see the same Z cross. So when you have the same base, but multiple times, what do you do the powers? Um, one, two, one.
Yep.
It's 2x to the power 2. Yeah. For step 1, we're going to use the distribution. In division, we distribute the power. So if 1, 2, 3, 4, divided by this to the power 4. So write it down. What to the power 3/4? We're distributing a power. 3/4 divided by the denominator to the power 3/4. And then it is a ruling for 1. That is 1 to the any power. The denominator, put parentheses instead of 56. No, don't have to put 56. Put parentheses. The denominator only. On the denominator only. So we keep 1 because this gives you 1. And here you want to replace 256 with something. So keep your 3/4 instead of 256. Go to the what is. So what number should multiply 4 times? 4. Fifteen times 4. One on the top, don't forget about that. The fraction 1/4. No, it's a fraction 1/64. Only 64 is a whole number. Fraction 1/64. Fraction, the small tiny. All these are
It's 14.
so make sure write all the rows down in one page and all the way I will increase it. Write down 1.5 nicely and continue with the point. 1.5 so I did our page with my morning class video on YouTube. You can watch that recording for the solution. And if you need any help, you can ask your advisor. And don't forget to do your homework. We did 5.1 and 10.2. 10.2 is not done yet. But you can start working on the homework. Have a good day. Be safe. Next 2 week, Tuesday. Yeah.
Have a good day.
You too.